Hello, I was going to start assembling one of my other projects a few days ago, which involves using some of these high force servos, and I found that these don't have an end stop on a mechanical one, so you can't tell without power where the rotation limits are or where the centre position is, which means I need to make a servo tester to be able to define the position before I can assemble that other project. Now, I designed something that could be used for that back in the early 80s, so I'm going to have to rebuild that to test these servos and set them up. And I thought it might be useful to other people with similar problems, or just wanting to test or mechanically or simply move, I won't say mechanically, simply move or drive servos without any kind of microprocessor involved or anything complex. All this uses is a 555 timer IC, 3 resistors, 2 capacitors, and a 5K or 4K7 pot. The circuit is there. It's just the left-hand half of that, purely the 555 section. I mean, this overall thing was a little project I did in 1978, which automatically moved a servo to a preset position in a radio control model if the radio signal failed or the thing lost range. But just the 555 part alone can be used as a servo tester, so that's what I'm going to build. So, unseal the 555. Now this is a bipolar one, it's a NE or LM whatever 555, so it's not a particularly static sensitive device, so I can put that in first. Don't normally use breadboards like these. I did do a very, very long time ago when I first started building computers, and I had no end of problems with them. I don't know if that was due to the quality at the time, if they were just economy ones that weren't very good, or if they're just overused or tarnished wires or what, but this is the first time I've used one of these in literally decades. I've just taken it out of an airtight pack, so it should be in good condition. The only preparation I've done is cut a few jumper wires from bits of telephone wire, so just stiff single strand wire, and put a bit of flexible and a 2-pin connector on a 5K pot, which is wired so anti-clockwise is lowest resistance, and rig up a 5-volt power connection to the prototype board using an off-cut USB cable that I got kicking about, and I've got a 6 amp USB supply used for charging various things just off the edge of my desk there. So anyway, to follow the circuit, pin 8 is power, so I've got pin 1 at this corner, so the opposite side is pin 8. That will link to positive bus. Pin 1 is negative, so use green. That's going to the negative bus there. And for the output, the connection to the servo, I've got a little piece of 3-pin header. It's actually a wire wrap header, I don't know, most people don't know what that is even nowadays, which will make a pin header when it's put in the board. Put that in the middle of the strip there so we can connect power at one side and signal at the other. And the actual connections to control it are the pot goes between pin 7, sorry, there's a resistor from pin 7 first, sorry, that's that 680 ohms. That goes from pin 7 to the pot and then on to power. So that's go from pin 7, I'll put that to somewhere a bit away so I've got room for other connections. and the pot will go from that to the next row down. The servo out of the way from it. Then that needs a link to power from the other end of the pot. And the timing components, there is a diode and a 47k resistor from pin 7 to pin 6 on the 555. Now, oh, that's something I meant to do. These resistors have still got a bit of sticky residue possibly on the ends because we've just taken them out of bandolier strips, you know, the masking tape type stuff. And I don't want to contaminate the breadboard with that sticky goo, so I'll get rid of that at the ends, just the last 1/4 inches off each end, 6-7 millimeters. Refit that resistor there. I'll take it a bit further out. So that resistor's going back from pin 7 to the pot. Then pin 7 to pin 6 I need a resistor, 47k. And I also need a diode. Now that has the cathode to pin 6, anode to pin 7. So that's cathode at this end, the band. That's between 7 and 6. And the timing capacitor for the 555 goes between pins 2 and ground, which is pin 1. So that's quite convenient. So that can just go there. And then it needs a jumper between pins 2 and pin 6. Which are those two. So that's the pulse generator or oscillator, whatever you want to call it, arranged. And now I need to just connect the output. So the centre pin on here, the red one is 5 volt or power, 5-6 volt power. The black or brown is ground, negative, 0 volts. And the orange is the pulse signal to the servo. So the centre one to power. The far end one to ground, 0 volts. Then another jumper, I need to go from pin 3, could have been a bit longer that one, but anyway, it'll fit, to that end of the connector. So in theory, if I've not got anything wrong, which is always possible, orange to the blue one there. In fact, no, I'll change that blue just for consistency. I'll change that blue wire to an orange wire. It's a reminder of which way around the connect. So that's pin 3 to the right hand pin on that connector. So left hand is ground, centre's power, right hand is signal. So if I put that in there, so the pot somewhere in mid position, I'll put the knob on it so it's symmetrical about the range, so I know what is centre position at a glance. Now if I plug this in, and with a bit of luck, I've got to plug the right way up, nothing happens. Okay, that's odd. And the servo's taking too much power. Oh, that's it. I was going to put another cap in because it's on a bit of USB cable, which is very thin and quite often quite high resistance. That's what the extra components for. Is a 100 microfarad capacitor. I was going to put across the power connections, just somewhere on the breadboard bus connections up there. Negative the right proper side to buffer it a bit. I have no idea why it's not working. I mean, I don't even know if that servo works. I've never tried it. Just check the voltage. Get this in so we can see. Hopefully. Yeah, there's a steady 5 volts on it. So power's okay. Now, I'm going to AC volts, check between negative and pin 3. There's definitely some pulsing signal on there. But it's not controlling the servo. Okay, so I don't know if it's the servo or the tester circuit. Just unplug the USB power. Take the servo off that pin header. I'm hoping this is still in camera view, yes. Let me try it on another servo. I've got some of these I've used in the past for small stuff. This is just a very generic, very cheap, basic thing. Only about £1 a piece on eBay. But it's a servo and it should take the same signal format, so I'll see what happens with that one. Now, right, okay, that works. So it's that servo doesn't like the signal for some reason. Sounds a bit rough, but it's been sat in a drawer for several years. It might have a dry spot where the gears are being meshed, and recently is redistributing a bit. The thing with this, you can take it past the end of the servo if you're not careful, so it will stall the motor at the end if the servo's got stops in it. So it definitely needs keeping near the middle of the range and be careful on the travel. But that's working as it should. Just try another one just for the sake of it. Now, I remember reading something about some of these very high power ones need a high repetition rate, whereas this circuit was built for the standard 20 millisecond interval. It may be that one's not liking that. It might need a shorter interval between pulses, which could be done by reducing the 47k resistor, which I might try in a minute. This is a little micro servo, an MG90S, which should work just the same as the other one I've just tried. Just put an arm on it so the position is clearly visible. Again, orange to the pin 3 output. Plug the right way around. Yeah, there we go. By switching between different pots or shorting out different combinations of resistors, you could have a number of preset positions for a servo that are controlled by a rotary switch or relays. if you didn't want to get into more complex programming on a project, you just wanted to be able to control positions by switched outputs. But as a tester, just a very basic tester, this works fine. It shows the work, and I'd actually have to put it on a scope to find the exact 1 millisecond pulse output that should be the midpoint of the servo. But just for testing movement or setting movement within a range, it's fine. And as you can see, a 555 and 6 of the components. We'll just try another of those high torque ones to see if it's that particular one or something in general. Oh, something else. Because I've been turning this by hand very gently, I wonder if it's stuck in a dead spot between the ends of the feedback pot. So I'll just turn it 90 degrees so it's definitely not in the same area that could be a dead spot, and try it again. Again, because I've never seen them before that have no limit, it's a problem I've not encountered. And that's just a possibility, so I'll just give it a try. Nope, still dead. That's not doing anything. Let me get another one out of the box. If it is dead, because it took about 2 months to arrive. Try and get these really high power ones at a sensible price. To get them off AliExpress. So you buy them in UK or from eBay, and the price is absolutely crazy for high force ones. So that one with the arm on it was the dead one. I'll put the arm on that. Won't turn this at all, just leave it as it is. Again, orange to pin 3, and plug it back in. Nothing. No. Now that's got... no, that one's alive. Just. Intermittently. Okay, I think it may be in pulse repetition rate then. It's trying, but it doesn't like it. That, or it's not got enough current available. Or it might even be high voltage ones, are they? No, it's 4.8 volts upwards. It's near the minimum. It could be running out of voltage, I suppose, if the power supply is a little bit low. You see, it's trying, but not happy. It's very intermittent, which is strange. I mean, it's not a fault of the tester as it is, because it obviously works fine with the other traditional servos, the more moderate power ones. I'll just try another resistor to change the pulse frequency rather than pulse time. Find a suitable value. Right, that's a 10k. It should reduce the repetition delay to about 4 milliseconds. Again, I'll chop the ends just in case they're sticky. Remove the 47k from pin 6 to pin 7 and fit a 10k pin 6 to pin 7. Okay, plug it back in and see what happens. No. Now that's it, still the same, it's just occasionally twitching, it's not the repetition rate then. I'll put that back to what it was. So I'm guessing it's supply voltage, because it's such a high power motor, it could be pulling the voltage down slightly if it's a little bit marginal. So it needs a 6 volt supply, which is worth knowing. That's it, what they go to, 7.4 volts. I think they're designed to work straight off of, not even that, in a single, two cells. Yeah, two cell lithium would be a reasonable range probably, with a regulator of some sort, and you can get it to stay to somewhere around 6.5 volts. But obviously it's not happy on 5 volts. Just verify that's working properly after the resistor change again. Now I will link to a copy of my original article for the RC failsafe device in the comments, all the information about the video. Yeah, that's it. So the circuit works fine, just those servos need unusual conditions. The normal ones were traditionally made to work from a 4-cell NiCad battery, so it's about 4.8 to 6 volts range, and they should work actually a bit lower. They should work down to something like 4 volts, which is where the NiCads would be dead flat. Obviously those newer ones are a bit more critical with being a lot high power. Update: the big servos do work, but they do need a higher voltage, and the motors take so much load they pull the supply down quite drastically when they do move. I've had to put 1000 microfarad capacitor directly across the power pins at the servo, and move the 100 microfarad capacitor directly across the 555 power pins, because just the resistance of the connecting wire and power buses is enough to make things unstable. The servo is modifying or modulating the power. If we take that capacitor out, sorry, the other noise in the background is my vector robot. It's decided to start snoring. Oh well. I was saying, if I take this capacitor out, the movement tends to keep getting a bit unstable and jumping about. It was a lot worse with the 100 microfarad right against the power input where it was to start with. So I'll put that back. That's a lot smoother like that. It also works slightly better, possibly, with the 10k resistor, though since I put the big capacitor on, I haven't tried changing that. I'll put that back to 47k. It's a lot simpler if it will work with that. So that's back to the original circuit and as first built. Yeah, the stability problem was just the fact that it's upsetting the 555 because of the amount of current it draws on that big motor in there. And so for 35 kilogram centimetres torque, it probably does take quite a massive amount, even for a fairly small sudden movement. But as you can see, that's working fine. It just needs 6 volts and an adequately rated power supply for the amount of current the servo takes. So that's it, thanks. Again, any questions or queries, please leave a comment.